So today in this lesson, we are going to be talking about sine and cosine of some angles. Like we learned 30 degrees sine of trigonometric ratios of these, for example, 45 degrees and 60 degrees using the right triangle trigonometry. Now, for example, in this lesson, we are going to have an angle in the second quadrant, in the third or in the fourth quadrant, but we are going to use these values. Okay, we are going to use these values. We are going to use the right triangle trigonometry. So let me give my first example. All right, so again, please mute yourself, and whenever you have a question, unmute and ask your question. All right, so let's remember this first. Let's remember this. For example, we have this right triangle. This is, let's say, 90 degrees. So this is, let's say, 30 degrees, and this is 60 degrees. So the side opposite to 90, let's say it is 1, because the unit circle, the radius is 1 in the unit circle. So we are going to dealing with unit circle here. So the hypotenuse is 1, right? The side opposite to 30 is always half of the hypotenuse, so it is 1 over 2. And the side opposite to 60 is always, root 3 times the side opposite to 30. So root 3 times 1 over 2 is root 3 over 2. So this triangle is going to help us to find some of the values of the trigonometric functions. Okay. So I'm going to start with 30 degrees. So let's say this is 30 degrees. Okay. This is always my initial side. Okay, so this axis is always my initial side. So this is going to be my terminal side, right? Terminal side. So this is 30 degrees. So this is our intersection point. And if you remember from the videos that I sent you, the y coordinate of this point is going to be sine of 30, right? Sine of 30. And the x coordinate of this point, because you know this is x and this is y. So x coordinate of this point is going to be cosine of 30. Okay. So now let me explain why. Why is it cosine of 30 and why is it sine of 30? All right. So let's have a right triangle here. Let's say this is our right triangle. This is our right triangle. You see, this is the hypotenuse, this is adjacent to 30, and this is opposite to 30. So what is the hypotenuse? The length of hypotenuse is 1, because it is a unit circle, and on the unit circle, the radius is always 1. So what is the side opposite to 30? The length of the side opposite to 30, it is 1 over 2. So this must be 1 over 2, right? And 90, 30, the third angle must be 60 degrees, okay? This must be 60 degrees. So what is the length of the side opposite to 60 degrees? So it is root 3 over 2. Root 3 over 2. You see, we have this right triangle here. So this is the length. So now we can find the coordinates. For example, the coordinates of this point, if this is root 3 over 2, if this length is root 3 over 2, this coordinate is root 3 over 2. And look at this. And the x coordinate of this point is root 3 over 2. Okay. And now, if this length is 1 over 2, let me find the y-axis, y coordinate of this point. Okay. So look, if this is 1 over 2, if this length is 1 over 2, this length is also 1 over 2. If this length is 1 over 2, the y coordinate of this point is going to be 1 over 2. So as you already know that cosine of 30 is root 3 over 2, it is cosine of 30, and this is sine of 30. All right, so now we can do it with another angle. For example, let's find the sine of 150 and cosine of 150. Okay, now I have my unit circle. So if this is this is 90 degrees, right? 90 degrees, this point, and this point is 0 degrees. Please, whenever you have a question, please stop me. Okay, so 150 degrees is going to be around this point, right? So all the way, let me draw the terminal side. This is going to be my, so the terminal side, let's say this is terminal side. All right, so this angle is going to be 150 degrees, is that correct? 150 degrees. So now the y coordinate of this point, what is this called? The y coordinate of this point, it is, and also x coordinate,
Sine.
yes, sine of 150, sine of 150, and this cosine of 150 degrees. Okay, so now we are going to find the value of sine of 150 and cosine of 150 degrees, and this is also x-axis. Okay, so let me erase these. Let me erase this, and I'm going to find the values, right? Okay, now look at this. If this is 150 degrees, if this is 150 degrees, how many degrees is this part?
30.
30. So 180 minus 150 is 30 degrees. Now I have a right triangle here. You see, I have a right triangle here, and this is 90 degrees, right? So this must be 60. So the interior angles add up to 180 degrees. Now we know that. Let's remember this. Let me. If you just don't remember, you are going to draw it. Okay, you'll draw it on your own. So 30, 90, and 60. The side opposite to 90, it is 1, because you see the hypotenuse is 1. The side opposite to 30 is 1 over 2. The side opposite to 60 must be root 3 over 2. So now, if the side opposite to 90 is 1, you see this is 1. The side opposite to 30 is 1 over 2. So that means if this length is 1 over 2, this length is also 1 over 2. And this point is above x-axis, that means it is positive 1 over 2, right? So now we should be careful here. Look, this length is root 3 over 2, because it is the side opposite to 60, root 3 over 2. But this point is on the left side of y-axis.
Negative.
Right? Yes, thank you very much. Negative root 3 over 2. This is negative root 3 over 2. So we can say that this is sine of 150. Sine of 150 degrees is positive 1 over 2. And cosine of 150 degrees is negative root 3 over 2. Cosine is negative in the second quadrant, and sine is positive in the second quadrant. The first quadrant, cosine is positive, sine is positive. The second quadrant, cosine is negative, but sine is positive. So far, any questions?
Can I ask?
Yes, please.
And cosine, we must draw a right triangle?
Yes, in each case, you can draw a right triangle, just like this. In each case, I'll give one more example, okay? So now the question was here, sine of 150. Sine of 150, we found 1 over 2. I'm sorry, this is 150. And cosine of 150 is negative root 3 over 2. Any more questions? No question? Okay, so now I'm going to
No.
mute you, Altanay. I have to mute because there is some sound coming. Okay. Now everybody muted, and please unmute yourself and ask your question. Stop me immediately. Do not hesitate. One more example, and then the last example you're going to try on your own, the last example. So now we are going to find cosine of 240 degrees and sine of 240 degrees. So these angles are in the third quadrant, 240, because this is 0, you know, this is 90, 180, 270. So 180 plus, what is 240? 60, right? So that's going to be 60 degrees. So it's going to be around here, I hope. So this is my 240 degrees. All right, so this is this angle. This is the initial side to the terminal side. This is 240 degrees, right? Okay, now we are going to find the y-axis of this point, this intersection point, the y-coordinate and the x-coordinate. And you already know that this is sine of 240 because it is y-coordinate, y-axis, and this is x-axis. So this is cosine of 240. Oh, okay, so the first thing we can say is both of them negative. Sine here is negative because you know this is origin, and above, below x-axis all the values are negative, and the left side is always negative values. All right, so let's start. Let me use another color. So is it 180 degrees? So this is 180 degrees. So 240 minus 180. So this part, this part is going to be 60 degrees, right? And we know that this is 90 degrees. So we are going to be left with 30 degrees here, right? So now we have another triangle, you see? 30, 60, 90, right triangle. Let's remember, let's quickly remember. If this is 90, and if this is 30, and if this is 60, it doesn't matter. It may be 30, it may be 60. What is important? This is important. The relation is important. The side opposite to 90 is 1. The side opposite to 30 is 1 over 2, the half of it. And the side opposite to 60 is root 3 times this.
1, yes.
Root 3 times 1 over 2, which is root 3 over 2. Okay? Okay, now let's write these values on this triangle, these lengths. Okay, be careful. I'm writing the length. So the side opposite to 90, which is the hypotenuse, which is the radius of what? Radius of this unit circle, it is 1. Does it look like a 1? Okay, so the side opposite to 30, it is 1 over 2. So this is 1 over 2, this length. You see this length, 1 over 2. And this length, it is root 3 over 2. And be careful, if this length is 1 over 2 units, then the coordinate of this point is going to be negative 1 over 2, right? Negative 1 over 2. Now you can answer. Please tell me what is the coordinate, y coordinate of this point. This point, because the length is root 3 over 2.
Minus root 3 of 2.
Thank you very much. Negative minus root 3 over 2. I hope this is clear. So now I can find cosine of 240. Cosine of 240. Cosine is the x value of this point, right? What is the x value? Negative 1 over 2. Negative 1 over 2 is the x value. What is the y value? y value is sine of 240. So sine of 240 is negative root 3 over 2. All right. Now we are going to do another example using this triangle. Let's say this is 45 and this is also, let's say, 45 degrees. The side opposite to 90 is 1 because the unit circle, the radius of the unit circle is 1. So these are going to be 1 over root 2 and 1 over root 2. Let me explain the reason. Because, you know, if this is 45, 45, so if this is x, this must be also x. It is x root 2. We learned this, right? So now, to find the value of these sides, we divide hypotenuse by root 2. If you divide x root 2 by root 2, you get x. So if you divide 1 by root 2, you get 1 over root 2. So 1 over root 2 is equal to actually root 2 over 2. 1 over root 2 is going to be equal to root 2 over 2 because we can rationalize the denominator. How do we rationalize the denominator? We multiply the numerator and the denominator by root 2, by the same irrational number. So 1 times root 2 is root 2. Root 2 times root 2 is 2. All right, so this is root 2 over 2. This is also root 2 over 2 if the hypotenuse is 1. So now, in this example, we are going to find in this, we are going to find the value of, let's find the cosine of 315 and sine of 315. So 315 from this all the way up to here, right? This is going to be, let's say, this point. This is my initial side. No, this is my terminal side. This point is the intersection point, and this is 315 degrees. All right. So 270, 0, 90, 180, 270, and 45 more. So now we are going to have a right triangle here. Let's say this is the x coordinate of this point. And let's say this is the y coordinate of this point, right? So this is going to be cosine of 315, and this is going to be sine of 315. So now we can say that this angle is 45 degrees because the entire angle is 360 and this is 315. 360 minus 315 is going to be 45. This is 45. And this is 90. So this is going to be 45 as well. So now we get this 45, 45, 90 special triangle. The side opposite to 90, which is hypotenuse, it is 1. The side opposite to 45, and both of them, this is an isosceles triangle, it must be
Root 2.
root 2 over 2, right? Root 2 over 2, let's remember this. Root 2 over 2. But we are talking about the length. This is the length. This is also the length. But what is the x coordinate of this point? If the length is root 2 over 2, it is positive root 2 over 2. And what is the y coordinate of this point? If the length is root 2 over 2.
Root 2 over 2.
Minus root 2 over 2.
Yes, thank you. Negative.
Minus root 2 over 2.
Thank you very much. Negative root 2 over 2 minus root 2 over 2 will be the y coordinate of this point. Okay, now cosine of 315. This is the intersection point. Cosine is always x value, right? So it is positive root 2 over 2. Sine of 315, it is going to be negative because it is the y value, negative root 2 over 2.